Hi guys, I'm Mr. Joseph, your chemistry teacher. Today's lecture is a continuation of our previous lecture on solutions and concentrations. Now, basically, in acid-base titration or in redox titration, there are situations whereby one of the acid or the base or the oxidizing agent or reducing agent used in the titration process might contain what? Water of what? Crystallization. So you'll be asked to find the amount of water of what? Crystallization. One use of titration is to find the number of moles of what water of crystallization in the substance. At times, they can even ask you to calculate the percentage of the water of what crystallization. So in such situation, we have to what calculate what the amount of water of crystallization or the percentage of water of what crystallization. So we're going to consider some questions. Normally, acid-base titration, where you'll be asked to what to find the value of what the number of moles of water of crystallization or the amount of water of crystallization or the percentage of what water of what crystallization. Please, I want us to listen attentively. We're going to take one or two questions and I'll be giving you a task at the end of the lecture, and I expect you to solve as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So let's move on to more to typical examination questions where you'll be asked to calculate the amount of water crystallization. So we're taking the first question, example 1. So this is a typical example. Example 1, let's take this. Washing soda has the formula Na2CO3.x moles of water. That means it contains water crystallization. So it's a hydrated salt that contains water crystallization. We have the hydrated and anhydrous salt. So a mass of 1.428 grams of washing soda was made up to 250 cm3. You make a solution. Then 25 cm3 of this solution we are neutralized by 20 cm3 of 0.05 mole per dm hydrochloric acid run in from a burette. So the equation for the reaction is given. Find the value of X and the formula of the washing soda crystal. The first thing you need to do is to read the equation, understand the equation, then look at the equation if the equation is balanced before you start anything. So, and also look at the values we are given. They gave us the mass of what? The washing soda crystals, which is the hydrated sodium carbonate. They gave us what? The volume, of the hydrochloric acid. You are given the concentration in mole per dm for the hydrochloric acid. You're asked to calculate the value of X. So the first thing we have to do, based on the values given, we have to calculate what the number of moles of what hydrochloric acid. So use the formula number of moles of hydrochloric acid will be equal to what? Concentration of hydrochloric acid times the volume of hydrochloric acid over what? 1000. We divide by 1000 because the volume is in cm3. So what is the concentration? We'll have 0.0500 multiplied by the volume of hydrochloric acid, which is 20, divided by what? 1000. So I'm to use my calculator. If I'm to use my calculator here, I'll have what? 0.0500 times 20 is equal to divided by 1000. So you have what? The number of moles of hydrochloric acid is equal to 0.001 what? 1 moles of what? Hydrochloric acid. Now the next thing to do is to look at the equation. So we write down the mole ratio of the washing soda crystals, washing soda to what? The hydrochloric acid. So the number of mole of the acid to the base, the mole ratio. So 1 mole of what? 1 mole of sodium carbonate reacts with what? 2 moles of what? Of HCl. Therefore, 0.001 moles of what? Of HCl will react with what moles of sodium carbonate. So you cross multiply. So you now have X now will be equal to what? 1 times 0.001 divided by 2. So 1 times 0.001 divided by 2. So you have what? It will now be equal to 0.0005 moles of what? Sodium carbonate. So this is the number of moles of sodium carbonate in 25 cm cube. So in 25 cm cube of this solution, will contain what? 0.005 moles of sodium carbonate. So we have to calculate the number of moles of sodium carbonate in 250 cm cube. So I have to erase this so that we have enough space. So we have, if in 25 cm cube gives 0.0005 moles in 250 cm cube, we'll have x. So you cross multiply. X now will be equal to what? 250 multiplied by what? 0.005 divided by what? 25. 25 here 1, 25 here 10. So x now will be equal to 10 times 0.005, which will now be equal to what? 0.005 moles of what? Of the sodium carbonate. That's the number of moles of sodium carbonate in what? In 250 cm cube. Okay, I have to erase this so that I will have enough space. So you are now asked to calculate what? Calculate the value of x and the formula of washing soda. So the value of x is the number of moles of the water of crystallization. So what we have to do, we have to what? We have to calculate the molar mass. So remember the formula, number of moles is equal to mass over what? Molar mass. Therefore, molar mass now will be equal to what? Mass divided by what? The number of moles. So the molar mass will be equal to what? The mass is what? 1.4280 divided by what? The number of moles, which is 0.005. So I'm to use my calculator. 1.4280 divided by 0.005. So you have what? To be equal to what? 285.6. So that is the molar mass of what? The molar mass of the washing soda. So I have to calculate the value of x. So to calculate the value of x, we'll have Na2CO3 point x moles of water be equal to what? 285.6. So sodium is 23, so we'll have 2 bracket 23 plus carbon is 12, relative atomic mass. Relative atomic mass of oxygen is 16, which is 3 bracket 16 plus x bracket what? 2 times 1 plus 16. So I have to erase this so that for a space. So it will now be equal to what? 285.6 as the molar mass. So this is 46. 2 times 23 is 46 plus 12. 3 times 16 is 48. Plus 2 times 1, 2 plus 16, 18. Plus 18x is equal to 285.6. So we now have 46 plus 12 plus 48. So you have what? 106 plus 18x is equal to 285.6. So therefore 18x now will be equal to what? 285.6 minus 106. 285.6 minus 106. So you have what? So I have to erase so that I'll have enough space to calculate. So it will now be 18x. 18x now will be equal to what? 179.6 divided by 18 divided by what? 18. Cancel that. X now will be equal to 9.97. So x is equal to what? 10 approximately. So that's the value of x. So the washing soda contain what? 10 moles of what? Water of what? Crystallization. So we have to get the formula of the washing soda. So the formula of the washing soda will be equal to what? Na2CO3 point what? 10 moles of what? Water. So as you can see, it's as simple as what? ABC. All you need to do is to read the question very, very well, understand the question, and use the values appropriately. Then look at the equation and make sure the equation is balanced. There are situations whereby you will not be given the equation. You're the one to write and balance the equation. There are situations you'll be given the equation and you'll be asked to balance the equation before you start solving the question. So it's as simple as ABC. I will expect you to attempt as many questions as possible. And if you have any difficulty, if you encounter any difficulty, please feel free to reach out to me. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So we're going to take another example again. I told you that the acid or the base might contain water crystallization. And you'll be expected to what? Find the number of moles of water crystallization and write down the formula of what? Either the acid or the base. Now let's take another example. Example 2. Ethane dioic acid has a formula H2C2O4.x moles of water. 0.900 gram of the acid we are made up to 250. 25 cm of this solution we are neutralized by 26.75 of what? 0.0532 mole per dm cube sodium hydroxide. We are given the equation for the reaction. What is the value of x, and hence what is the formula of ethane dioic acid? As you can see from this question, it is the acid that contains what? The water of crystallization. So we have to find the number of moles of the water of crystallization in the what? The acid. So it can be the acid, it can be the base. If it's a redox titration, it can be the oxidizing agent or the reducing agent. So as just like the previous one, the first thing for you to do is to look at the values. Make sure you understand the question, then look at the values you are given. So the first thing we have to do here is to calculate the number of moles of sodium hydroxide, because we are given the volume of sodium hydroxide and we are given the concentration in mole per dm cube of sodium hydroxide. So number of moles of sodium hydroxide will be equal to what? Concentration of sodium hydroxide multiplied by the volume divided by 1000. So the concentration in mole per dm cube of sodium hydroxide is 0.0532 times the volume of sodium hydroxide, which is 26.75, divided by what? 1000. So what we have to do here, you pick up your calculator, as simple as ABC. So we have 0.0532 times what? 26.75 is equal to, divided by 1000. So you have what? 0.00142311 moles. That's the first thing to do. So you've calculated the number of moles of sodium hydroxide. Now you go to the equation. 1 mole of the acid reacts with 2 moles of sodium hydroxide. So the mole ratio is 1:2. 1 mole of what? H2C2O4 reacts with what? 2 moles of what? Sodium hydroxide. So 0.0014231 moles react with what? 1. So you cross multiply. So you now have what? 1 times 0x now will be equal to what? 1 times 0.0014231 divided by 2, which will now be equal to 0. I think let me put it here. X now will be equal to what? 0.00071155 what? Moles. So this is the number of moles of sodium hydroxide in 25 cm3, because it's 25 cm solution that was neutralized by the sodium hydroxide. So this is the number of moles of the acid in 25 cm3. So we have to calculate the number of moles of the acid in 250. So what we have to do is erase this for enough space. So this is the number of moles in 25, number of moles of the acid in 25. So to calculate the number of moles of the acid in 250, so we'll say in 25 cm3, we have 0.000071155 moles. So in 250 cm3, we'll get what? X. So you cross multiply. You now have 250 times 0.000071155 divided by what? 25. 25 to 1, 25 to 10. So you have what? X now will be equal to what? 0. What? 0.0071155 mole of what? The acid A2C2O4. Okay. So this is the number of moles of the acid in 250 cm3. So what we have to do, we have to calculate the molar mass of the acid. Remember the formula, number of moles. Remember the formula, number of moles is equal to mass over what? Molar mass. Therefore, the molar mass now will be equal to what? Mass divided by the number of moles. So the mass in 250 cm3 is 0.900 over the number of moles in 250 is what? 0.0071155. So I have to erase this. Okay. So let me use my calculator. So 0.900 divided by 0.0071155. So you have what? Molar mass. Molar mass now will be equal to what? 126.48. So that is that. Now I haven't gotten the molar mass, so I have to calculate the value of X. So this is the molar mass of what? Of the ethane dioic acid. So A2C2O4 point what? X moles of water to be equal to 126.48. So hydrogen is 1, so we'll have 2 brackets 1, plus carbon is 12, 2 bracket 12, oxygen is 16, 4 bracket 16, plus X bracket, hydrogen is 2, hydrogen is 1, so 2 times 1 plus 16. Okay, let me erase this so that I'll have enough space. So let me do that. Okay, so you have 2 bracket 1, plus carbon is 12, 2 bracket 12, plus oxygen is 16, 4 bracket 16, plus X bracket 2 times 1 plus 16 will be equal to what? 126.48. So hydrogen is 1, so 2 times 1, 2, plus 2 times 12, 24, plus 4 times 16 is 64 plus 2 times 1 2 plus 16 18. So we have 18x is equal to what? 126.48. So erase this. 2 plus 24 plus 64 is equal to, so we'll have 90. 90 plus 18x is equal to 126.48. Is that okay? So 18x now will be equal to what? 126.48 minus 90. So 126.48 minus 90 will be equal to 36.48. So I have to erase this so that I will have enough space. So 18x now will be equal to what? This is equal to 36.48. So 36.48 divided by 18, divided by 18. Cancel out. X now will be equal to what? Divided by what? 18. So you have 2.02. So x is equal to what? 2 approximately. Therefore, the formula of heating acid is H2C2O4.2 moles of what? Water. So as you can see, it's as simple as what? ABC. All you have to do is attempt as many questions as possible. Read through the question, make sure you understand the question very, very well, and apply the right words, apply the right formula. So please try as much as possible to solve as much questions as you can. Please, while solving questions, if you encounter any difficulty, please feel free to reach out to me. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel, like, comment, and share. I'm Mr. Joseph, your chemistry teacher. So before leaving, I'll be giving you a task. Please, I want you to attempt the task and also solve as many questions as possible. Please, if you encounter any difficulty, feel free to reach out to me. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So I'll be leaving the task now. So let me give you the task. So this is the task. Please, I want us to attempt this question. Please, if you encounter any difficulty, feel free to reach out to me. Solve as many questions as possible. And please attempt this task. And in our next class, continue from here. I think we might take the correction in our next class. I believe that if you have listened attentively to the lecture, I believe you'll be able to give the accurate answer to this particular word question. So thank you very much for listening. I'm Mr. Joseph, your chemistry teacher. Thank you very much.